Good morning, Mr. Lesham is here. We are carrying on with function or inverse function, and this time we're going to look at the graphs. So we're going to plot graphs of a certain function, okay, and then plot the graph of the inverse function and see that there's some things that are always the same. So as an example, we'll use this, okay, write it down a little bit lower, use light here. So we've got f of x equal minus 3x plus 3. Now, what I want to find out first of all, and I'll do it quickly because we spent the whole last lesson doing it, let's find the inverse function. Okay? So your first step, okay, if you remember, whenever it's written as f of x, just write it in terms of y. So y equal minus 3x plus 3. Huh? Then that was, we call it step 0. Step 1 was swap them, okay? So we get, wherever we have x, we're going to write y. Wherever we have y, we write x. Okay? That was step 1. Step 2 is to solve for y. We want to find out what the y is. Okay? So if I move the y over to this side, so it's going to be x minus 3 over, it's going to be x minus 3 over minus 3. Okay? So I just move the 3 to the other side, divided by minus 3. And then rewriting it slightly nicer, I can write, to get rid of that minus, I can say, okay, so it's minus x plus 3 over 3. Okay? Right? And then finally, I just want to check that I've got it right. Yeah, it's okay. And then I'll write it down as the inverse function. It's going to be minus x plus 3 over 3. That's the inverse function. Okay? So that was last lesson. I'll get rid of that because we don't need that anymore. What I'm interested today is to plot these graphs. So what kind of graph are these things? What do they look like? What does this look like? What can you tell me about that? Looks like it's a straight line. So first thing, it's a linear function, it's a straight line. Okay? Is it going up or is it going down? Down. It's going down. The gradient is minus 3. Okay? It's going down, so it's going to be something like that. What will be the y-intercept?
3.
It will be 3, because if you put 0 here, then you end up with a 3. What will be the, and let me just adjust it a little bit to make it a bit more realistic. Okay? What will be the x-intercept?
1.
Okay? What will this be?
1.
Correct. That will be 1. If you put 1 here, minus 3 plus 3 is 0. Okay? Alright, let's try and figure out this one. Okay, so to make you understand that better, I can write it again as this. I can just divide everything by 3. So it's going to be minus third x plus 1, isn't it? Can you see how I went from here to here? Right? And now we can try and maybe draw the inverse function. First of all, is it going up or down?
Down.
It's going down. Is it more steep or less steep than this?
It's less.
It's less steep because the gradient is a bit closer to 0, isn't it?
Yeah.
Okay? The gradient is minus 3. Okay, so we're going to go like a bit more gentle. What will be the y-intercept? 1. When I put x, okay? If I put x equals 0, the y-intercept is 1. What will be the x-intercept? What should x be for this whole thing to be 0? 3. If I put 3 here, minus 3 times 3 is 1, or minus 1. Okay? So that should be 3. So we get a line like this. Okay? So this is going to be f minus x, and this is going to be f of x. And we're noticing a bunch of stuff. Okay? I'm also, to be able to see all the things that we need to notice, where's my green? I had a green. Here it is. Okay? I'm going to draw one more line, this line. Okay? This line is the line y equal x. Y equal x. Okay? It's angle 45 degrees. So it goes to 1, 1, 2, 2, 3, 3, minus 5, minus 5. Okay? Now, what I want you to do, I'll pause the camera. I want you to have a look and see, what can you tell me about these two graphs? The red and the black. So you guys came up with 4 out of the 5 things. So the first thing you guys said very well, Aaron said, that the x-intercept in the inverse function is the same as the y-intercept is the x-axis. I'm not going to write it down, guys, but it's all written for you in page 41. Okay, so you can read it there, you can highlight. If you want to copy it, you can copy it. I'm just going to go through it. So again, the x-intercept of the inverse function is the same as the y-intercept of the function. Okay, this is 0, 3, this is 3, 0. Oh, sorry, this is 3, 0, this is 0, 3. The x-intercept of the function is exactly the y-intercept of the inverse function. Then Leon said that there is a symmetry. These lines are symmetrical. So we need to understand what does symmetry mean, okay? If you take this line, y equal x, this line 45 degrees, and you flip the red graph around it, what you will get is your inverse function. And it's the other way around as well. If you flip the function, you flip it around the x, if you flip it around here, you'll get that. Okay, so there's a symmetry. Okay? If I take this and I flip it around here, then if I flip it around this line of axis, if I put, let's say, forget about flipping. If I took a mirror here, if I put a mirror,
yes.
and what will be the reflection of that one? It will be like that one. What will be the reflection of that one? It will be that one. Yeah? That's the symmetry. So there's symmetry around the line of y equal x. Okay? And then there's two more things that we need to say. Let's take another, if I put 2, 0, let's find out, no, let's go with this one. Let's see what happens when x is equal to, let's put 2 here. When x is equal to 2, we want to ask ourselves what happens when x is equal to 2. What's the point? If I put 2 here, what will be the y in the function? Put a 2, so it's minus 6 plus 3 is? Minus 3. So the point is 2 minus 3. Okay? Now, what I'm going to say here is for every point like that, if I'm looking at the minus, if I put x equal minus 3, what do you reckon the y should be without calculating?
Negative 2 and 3.
Negative 3 and 2.
Negative 3 and 2.
Okay? So for every point, if x is 2, y will be minus 3. If I put x is minus 3, I'm claiming the y should be 2. And let's see if that's true. If I put minus 3 here, so it's minus minus 3, it's 3. 3 plus 3 is 6. 6 divided by 3 is 2. Okay? So it's like a magic. If you put 2 minus 3, then on the inverse function it should be minus 3 over 2. It works out with anyone. I can take a number, let's say I'll take an x that is a and the y is b. Okay? If x is a and the y is b, then guarantee, guys, that on the other side, I'm going to have a coordinate which will be what? What will be the x and what will be the y? B and A. That's what it means when we say these lines are symmetrical. That's what it means, okay? And if you think about it, I'm not going to get into too much. It has to be done because that's exactly the idea of an inverse function. That's what we began the lesson. I wasn't doing in the camera. If you take an input A, you'll get an output B. If you feed that output B in your inverse function, you must get back your original A. That's exactly the definition of the inverse function. Okay, last thing I need to say is that all these guys meet up at one point. All these lines meet up, intersect at one point. And if you think about it carefully, they have to intersect at one point. Because here, I don't know what I'm going to have. Shall we try and find out?
Yeah, you just made out.
They don't ask us to do it, but
the equations equal.
yeah, exactly. Let's call this C. Let's say we have an intersection. We can find out. We can calculate. You know how to do it. Okay. All I gotta do. How do I find this intersection? What do I need to do to find where these points intersect? Forget about the black, the green line, but the red and the black.
Make them equal.
Make these two things equal, right? Okay. Now, I'm not going to do it. You guys can do it. You know how to do it. But what I'm claiming is that if this is C, whatever it is, it's probably somewhere between, it's a little less than 1, it looks like, 0.5 or 0.7. What will be the Y? Guys, it has to be the same. Because if I flip it, the other point is it has to be the same. Because first of all, it's on the line y equals x, so it has to be the same. Okay, I know I'm kind of throwing a lot of stuff, so let's just accept that. Okay, so I'll repeat the 5 things. Okay, first of all, these 2 lines, the function and the inverse, are symmetrical around the line y equals x. That means a couple of things. It means that the x-intercept in the inverse function will be equal to the y-intercept in the function, and the y-intercept in the inverse will be equal to the x-intercept in the function. It also means that for every point BA, I'm going to have similar point AB. And it also means that they all intersect in the same point over here. Okay? I'll pause for questions. Right, so they did ask me to draw the lines, asked me to draw the line of symmetry, but now actually they're trying to asked us to find out the point intersection. So I will follow as you guys said. All we gotta say is minus 3x plus 3 must be equal to minus x plus 3 times 3. Okay, so these 2 must be equal. Okay, and then we solve for x. Okay, so I'll personally will time everything by 3. Minus 9x plus 9 equal minus x plus 3. Move the 9x over here will be 8x equal minus 6, meaning x equal minus 6 over 8, which is minus 3 over 4. Yeah, we did say kind of just under 1. Hang on.
It's not minus 6.
Yeah, it's good. Yeah, that should be plus. So 3/4. Okay? Now, I've been asked what's the coordinate. So I only have half the answer, right? What's the other half the answer I need? That?
It's the same.
Yeah, but what am I looking for? You tell me how to do it. The y. I need to know the y. Now, if what I say, I can automatically say, what should be the y? It has to be 3 over 4, because we said that they all intersect on the same line. The line here, y equal x. But let's just do it for once. Okay, so to find out this, I'm going to say, okay, y is going to be equal to minus 3 times 3/4 plus 3, which is minus 9 over 4 plus 3, which hopefully is 3/4. Okay, is it? 3 times 4, I can say it's 12 over 4, and yes, that is 3/4. So it does work. Okay? Okay, I'll pause here and see if we need to do another example. As our next example, keep putting on the lights. Is it another example we did, y equal x squared. Okay? Maybe let's start, and again, they're asking us first of all, and that's the kind of question they're going to ask us. They're going to ask us first of all to find the inverse function, then plot the graphs. Okay? So let's start with actually plotting what is y equal x squared. What does that look like? It's a parabola, right? It's the first parabola, it's actually the mother graph. Okay? Y equal x squared. Okay? Now, if you remember, we actually did this example to find their inverse function. So I'm just going to go through it very quickly. To find their inverse function, first of all, swap, and then solve for y. But do you remember what I had to do? Or I haven't done it yet. Plus minus over multiply. Okay? There's really 2 solutions. And I actually drew it for you last time. Okay, so it's not going to be the first time, but now hopefully it will makes more sense. If I want to draw that, this is something you've never worked with. We never really plot that function, because in fact it's not even a function. Remember, we spoke about that. Okay, but now if you believe what I said, that these graphs are going to be symmetrical around the line y equal x, then hopefully you can figure out that. Let's do it in red. Okay, so what I'm going to do, I'm going to just, I kind of know what it looks like, so it's more difficult when you don't know, but it's going to be symmetrical around that, right? If you flip, if I put a mirror here, okay, I will get that, right? If I put a mirror and I draw this blue thing, I'm going to get that. If I take a mirror and I look at what this one looks like, this is going to go there, and this is going to go there. Can you see? That's the line y equal plus minus square root x. That's the function, that's the inverse function. Okay? The intercepts are 0, 0, and they're all crossing the same place here. Okay? Are we happy with that? Okay? I really recommend you to actually almost memorize, know how to draw these things, because I think if you had to draw it just from understanding in the test, it's going to be very confusing. Okay? But maybe that mirror test does help you, no? You just put in here and you say, okay, what will be this look like? Oh, it will look like that. What would this branch look like? It would look like that. What would this branch look like? Like this. Okay? Right, let's move on to the next. So I'm just consulting the book here and I realize that this is not complete. When they ask you to sketch the graph, but what did I forget to do? I need to put some coordinates. So one of them is that 0, 0. I don't know if, just to be safe, let's put it in. I don't have x-intercept or y-intercept, so I don't need to add them. But what you are required, even though they never really tell us, is to find their coordinates where they meet. Okay? How are we going to find that? How are we going to find that? Let me ask you that question. Right. So I'll ask you how to find them, and Aaron said again very correctly, we can just say that these two are equal. Now absolutely what? You can do it. But let me show you this time maybe a bit easier, because we know that these graphs intersect not just each other, they also intersect y equal x. So instead of making these two equal, I can just take, let's say, the first one, because this is like, I don't know what about that, it's a little bit kind of tricky. I'm going to say y equal x squared must also intersect, not just this one, it also intersect y equal x. So let's make these two equal, x squared equal x. Okay? Because look, they're not just in the blue and the red not intersecting, they're also intersecting the green, and the green is always going to be dead easy, y equal x, it's always y equal x. So let's make them intersect. Like I said, you are totally allowed to write these two are equal, but then you have to square it, it's a little bit more difficult, but it's fine. Okay? So in this one you can solve very easily. Okay? What should we do here?
X.
How do I solve for x here?
It's a what you call it now?
Let me get you started. First of all, move everything. Well, what shouldn't you do? We shouldn't divide by x. Some of you might divide by x. If you divide by x, you're going to lose a point. Because if you divide by x, then you're going to say x equal 1, right?
Honestly, you take the common factor.
That's it. So you got to take the common. First of all, move it to the left. Take a common factor, and then you're going to get that. And now I have two solutions, right? X equal 1, which we would have got here, but we would have lost x equals 0, which we know these two will intersect also in x equals 0. So x equals 0, and the other one is x equal 1. What will be the y-intercept? I don't even need to calculate. Not y-intercept. What will be the y-coordinate? 1. It has to be. Wherever they intersect, the x and the y are the same. Remember? You can put it, you can sub it in here again, x equal 1, you'll get y equal 1, but it's always going to be the case. So we've got that. Okay? So we got the two bits where they intersect. But they tell me, I'm looking at the book and we want to get full mark. It looks like we also need 2 points here. Any 2 points, it doesn't matter. Any points. So which x could we use on this one? I mean, let's look at the blue. Okay, so obviously we have a point on the positive, we want a point on the negative. So which x do we take? Negative 1. So if we put negative 1 here, what will be the y? 1. So it's going to be negative 1, 1. Okay? Now, you know, I can take, if I want, I can take any points. But remember, these things are symmetrical. So if I'm going to have positive 1, what will be the y? Negative 1. Okay, so you don't even need to calculate. Okay? Pause here. Last example for today. Y equal minus 2x squared. Okay? Let's plot it. Okay? What is that going to look like? It's a parabola, but compared to the other parabola, this one is a? It's upside. It's a sad face. It's a negative one. Still going through the x 0, 0 because there's no plus sign. Okay? Right, let's find out the y-intercept. First of all, we swap. X equal minus 2y squared. Solve for y, we're going to say y squared equal minus x over 2. Is that right? Okay? Yeah? And then take a square root, so it's going to be plus minus square root of minus x over 2. So we had a minus inside there. That's, we're going to talk about why do we have to that minus and what does it mean. So I need to be able to draw that. But now drawing this is difficult for us. So we're going to use this idea that these functions are symmetrical along the line y equals x. Okay? We're gonna do that. Okay? So I really like this idea of a mirror. I don't know about you, I really like this idea of a mirror. So I'm gonna start by I'm putting the mirror here, and I want to see what happens to that line. Well, that line is gonna do something like this, right? I'm plotting now this function. Okay? So this line, this branch will look like this, pretty much, right? Then I'm looking at this line. Well, this line will do something. It's not crossing, so it's like this. Yeah? Can you see it?
Mm-hmm.
And this line is going to look like this. Yeah? Yeah, this is really good. I really like this mirror method. Okay? And you can see now it looks very similar to what we did. So we're good. Okay? Now we've got, what are we missing now? Coordinates. So we need to get the intercepts. Okay, this one is 0, 0. That's pretty easy. We need to figure out that one. Okay? So I'll start with a function. It's always better to work with a function because it's not nice to work with this plus minus. What does that mean? Okay? So minus 2x squared. What should I say it's equal to? 2? Because normally we say, all right, these two intersect, let's make them equal. But we have a square root there. We said I showed you a shortcut, right? It's just equal to x, right? Because it's not just the the function and the inverse function are intersecting. They're also intersecting the line y equals x. So let's make it equal to x, and that's dead easy, right? So I'm going to move it to the other side and take the common factor, like Simon said, and it's going to be something like that. Yeah? Minus a half, you're right, minus a half is the x. Okay? Now without calculating, they actually didn't even do it, but it's good, we should do it.
Is it not negative
X, either x equal to 0 or x equal to negative half, yeah? What will be the y? Without even calculating. Has to be negative half, because they're all, the x and the y are the same, okay? Right? Now, just for the fun of it, let's get 2 more points on this one. Did they get? Yeah, they got 2 more points. Okay. So if I take, what should we take? X equal what? Pick a nice number. 1. Okay. X is 1. Okay, let's put it over here. If x is 1, what will y be equal to? Come on, put 1. It's not difficult. If I put 1 here, what was the y?
Negative
4.
Negative 2. Okay? We're squaring the 1, we're timing by 2.
I think that's right.
Okay? 1 minus 2. Okay. Without much thinking, what will be a point here? If this is 1 minus 2, this will be? Negative 2. 1. You just swap them. Okay? To be on the safe side, like we did in the same here, let's go with another point which will be, let's say, minus 1. What will be the y? You can do it without really thinking too much. If this is probably, if I take x equal 1, I get minus 2. It should still be minus 2. That's important checking, but minus 1 squared, it's 1 plus minus 2. Okay? And what will be this point here? The symmetrical point. If this is minus 1, minus 2, this will be? Minus 2, minus 1. Okay? Then we definitely have enough points for them. They can't accuse us that we didn't do enough. Okay, I'll stop here. We'll do some more example next lesson. Let's work now.